Now, this next and actually last part of this chapter is a chapter that students usually find very difficult. And indeed, the reason they find it very difficult is because they have to think. And thinking is bad. We all know this. But we will try our best. Okay? So it is difficult. And the problem is that I can do a couple of examples, but each question is different. So you have to try and figure it out yourself. But I'll give you a couple of examples just to get you the idea of what's happening here. So these are called practical problems. It's actually our first lesson on practical problems, where we have to read the situation and use formulas to solve it. Okay? So let's have a look at, as an example, the first one. The first one I won't do, but I'll just talk about it. The question is, what is the sum of the first 100 integers? What are the first 100, or what is the first 100? What are the first 100 integers? 1, 2, 3 to 100. So the first question is to add those numbers together. Is that AP or GP? AP. What's the A? And the the D? 1 and the N? 100. And which formula do you need? UN or SN? SN. Sum. Okay. Let's have a look at the second one though. Anne invests in a bond that pays €25 in the first year, €50 in the second year, €75 in the third year, and so on. How much does the bond pay over 10 years? So she has this bond. If you don't know what a bond is, it's coupon actually is actually not a bad word for it. Yeah, like a savings certificate. It pays you money each year. So it pays you 25 in the first year, then it pays you 50 in the second year, and 75 in the next year. Yeah. Coupon is the right word here. Well, no. So, what type of sequence is this? Is it AP or GP? It's AP. And what's the A? A is 25. D, 25. And N, 10. And do I want UN or SN? SN. I want SN. Or S10, really. Which is N over 2. 2A plus N minus 1 times D. Can you type that in? It's going to be, let's see, 5 times 50 plus 225, 5 times 275. Is that right so far? What do we get in the end? 1375? Yeah. So that's how much you get in total over 10 years. Okay. I will do as another example. I'll do number 3. Number three I've seen in the exam lots of times, worded different ways. But number 3 I've seen lots of times. So let's have a look at number 3. Can I scroll down? Yeah? Not yet? Okay. Okay. Can I scroll down now? Yeah. So number 3. I tell you the sequence x1, x2, x3. I tell you that this is arithmetic. I don't tell you what x1, x2, and x3 are. I just tell you it's arithmetic. I then say, of the same sequence, the first, the second, and the 11th term are geometric. What does that mean? I'll go back to this in a moment. Let me just give you a little example so you have the idea in your head. Let's say what type of sequence is this? AP. What's the A? 2. And the D? 2. This is the first, second, third, fourth, fifth, sixth term. Now, if I was to take out the first term, it's 2. The second term is 4. And the fourth term is 8. What type of sequence is this? Is GP. What's the A? 2. And the OR? 2. So what's happening here is they give you an arithmetic sequence and they tell you that if you take out these 3 numbers and make a new sequence, that sequence is geometric. This is what's happening. So if I go back to the question now, we're told that we have an arithmetic sequence, but the first, second, and 11th term is geometric. Okay. So let's start off with arithmetic. If it's arithmetic, what's the first term? A. Second term? A plus D. And then the third term? A plus 2D. So this is the arithmetic. Now, if this is geometric, what's the first term? A. Second term? AR. And then the third term? AR squared. Now, don't make the mistake of putting 11 here, because this is a new sequence. So this is now the first, second, third. Okay, so the mistake to make would be to write 11 here, or 10. It's not, it's 2. Because this is a new sequence from the original. Okay. Okay, so we actually know that these numbers are the same. Well, of course we do. They're both A. And they're both x1. But we know that x2, these two numbers are the same. See? There they are there. Okay. These ones, though, they're not the same. Okay, so we can't really compare these here.
Why can't you compare x2 and x2? Why can't you say that?
Oh, we can, but we can't do it for the last one. So what we do instead is we forget about this for the moment. Okay, so let me scroll down so it's out of sight.
But we already have that x1 equals 1.
Oh yeah, no, I'll use that in a moment. Yeah. So we forget about that and we just look at this. This sequence is arithmetic. This sequence is geometric. Maybe some of these numbers are the same. Maybe they're different. Sometimes they're the same. Sometimes they're different. But what we do know is if I take this number here and divide it by this number, what do I get? I get OR. And if I take this number here and divide it by this number, what do I get? I get OR. So now I go back here. This is like A. This is like A plus D. And this one here is like A plus 10D. So we forget about this for the moment. And we use the comparison I just made. So we know that the second divided by the first, the second divided by the first is OR, and the third divided by the second is OR. That means this one divided by A is OR, and this one divided by the second is also OR. That is so confusing, I'm going to do it again. Okay. We have this is arithmetic. So it's like A plus AD plus A plus 2D, etc. But we're told that this one, and the 11th one is GP. But it's still arithmetic. It still comes from the original. So this term here is still A. This one here is still A plus D. This one here is still A plus 10D. It's still coming from the arithmetic. But we're now told it's also geometric. So if it makes a new geometric sequence, this is A, this one here, AR, and this one here, AR squared. This divided by A, what is it? Or. And this one divided by this one here, what is it? Or. So it's true that this divided by this is or, and then this one divided by this one here is also or. So we can make this equation. A plus D over A equals or, and A plus 10D over A plus D, that also equals or. So this is the key step here in solving this problem. Look, it's a key. This question here is really important. It's, of all the questions on this page, it's the one I've seen in the exam the most. I think I've seen this 5 or 6 times in the exam. Okay, so of all the questions on this page, this is the one you definitely need to know the most. Okay, so we can continue here. This is A plus D equals A or, and this is A plus 10D equals or times A plus D. Now we want to solve this. So what would I get out here? We see we have A, D, and or. So I could use substitution. Should I try and get the A, the D, or the or? What do we think?
The A is given as well.
Yeah, the A is given. So actually, let me write it again, but with the A given, actually. So what do we say in the question?
A is...
Yeah, I say x1 equals 1, so therefore A equals 1. So let me just write this again. 1 plus D over 1 equals or, and then 1 plus 10D over 1 plus D equals or. I think the best way to solve this is because they're both equal to or, I can just make them equal to each other. Okay? They're both equal to or, so I can make them equal to each other. So I have 1 plus D over 1 equals 1 plus 10D over 1 plus D. Now it's not so bad. Bring that up, bring that up. So I get 1 plus D times 1 plus D equals 1 plus 10D times 1. So I get 1 plus 2D plus D squared equals 1 plus 10D. So I get D squared minus 8D plus 0 equals 0. So it's a quadratic with D equal to 1 or 8, isn't it?
D equals to 0 or 8.
Sorry, 0 or 8. Sorry. 0 or 8. So we have the D. How can I find the A? Well, I know the A. How can I find the or? We have it back here, don't we? Or equals 1 plus D over 1. So it'd be 1 plus 8, which is 9, over 1, which is still 9. So therefore, or equals 9. So I have the D, I have the or, and I have the A. So I know the sequence. Yep. It can't be 0 because it would mean that all the numbers are the same. And in fact, I didn't say it in this question, but in the exam they will say non-constant sequence. So that means I can't use that one, because then all the numbers are the same if D is 0.
And if they don't say that, then it might be 0.
True, yeah, but I've never seen that.
It is 0.
But if D is 0, we cannot.
Yeah, it will still work in both ways.
If D is 0, or? Or will be 1.
Yeah, and still it would be the same.
Yeah. In other words, the answer would be, if you took D as 0, the answer would be 1, 1, 1, 1, 1, 1, 1, 1. Is this arithmetic?
Yeah,
Yeah.
but it's not. It doesn't make sense when you get R. So it's R.
Is 1.
R is 1.
Yeah.
1, 1, 1, 1, 1,
Yeah.
1, 1.
Hold on. Yeah, go ahead. No, go ahead, yeah.
But R shouldn't be 1.
You're right, it shouldn't be 1. Yeah. And D shouldn't really be 0 either. Yeah. The reason we don't use it is because it makes this answer, and this answer is stupid. Because it's not really an answer. We're just using the same number. What? Hang on. I'm dealing with this right now. You're not happy. I don't know why you're not happy. Tell me why you're not happy. That's not the reason.
That's the answer.
I think the answer to D is only 8.
Yes, you're right. Yes.
I know.
Okay, great. Right, so we go on. So we don't take D as 0, we take D as 8. And or will be 9. So let's calculate the arithmetic sequence as an example. So what's A? 1. And what's D? 8. So what will be the next term? 9. And then the next term we add 8 again. 17, etc. Let's go to the 11th term, which would be A plus 10D, which would be 1 plus 80, 81. Now, what terms did I tell you to take out to make the geometric sequence? The first, the second, and the 11th. So what would that be? 1, 9, and 81. Is that geometric? Yeah, what's the A? 1, and what's the or? 9. So we've made an arithmetic sequence that has a geometric inside it on the first, second, and 11th term. Okay? This question, I know it's difficult, but the good thing is it's common in the exam and it's the same way each time. You see that trick here of dividing is the same every time you see this question. Every time you have a geometric inside an arithmetic. Okay, so I only have one of those questions on this worksheet. But when we do past questions as revision, we'll see this frequently. So it's important in your notes that you make a note with this question that it's important, okay? Because I only have it once. But you need to see in your notebook that it's important. So please write at above the answer here that it's an important exam question. And the key symbol if you like, yes.
Number 4, when it says that it flies further than 10 meters, means that by 5 meters, then it's by 10 meters.
Yes.
So
Yes.
the sequence is not 5 centimeters, it's 5.
This is the thing. You can look at it either way. You can look at the sequence of each distance travelled each second, or what you're doing is looking at the displacement. That's not arithmetic or geometric, is it? So you have to look at each piece. And then I think I want the total distance travelled, which means it's the sum of each piece. What I'd like you to do now, for the next 9 minutes, I want you to do all the other questions. So I've done 2 and 3. So I want 1, and then 5, 6, 7, 8, 9, 10, and 11. I should also say that number which one? Number 7 was a past exam question.
Which year?
2 years ago. Okay. So you can start these now. They are difficult to, it might take you some time, okay? 1, 4, 5, 6, 7, 8, 9, 10, 11. All the other questions. We have class tomorrow, don't we?
Hopefully not.
True. No, I share this feeling. I'll check these ones tomorrow, but I have a feeling that our tutorial class on Monday will probably be used up with lots of these. So try your best. You can start from now. 1 second.